Hi, my name is Megan Coffey. This is my lab 4. So as an introduction to the lab, the purpose was to measure the distance dependence of the magnetic field due to a small bar magnet and compare it with the expected values for the on and off axis magnetic fields. The models and principles we used in this lab were the Biot-Savart law and knowledge about magnetic fields and distance dependence. And then for the preview of our result, we found a distance dependence value to be about negative 3.077 meters and the magnetic dipole moment of the bar magnet to be about 3.06 amperes squared. And then the experimental average magnetic field at the off axis was found to be about 4.59 times 10 to the negative 5th Teslas. So these are the models and principles that we use. The Biot-Savart law, here we use the parallel dipole on axis formula, and then the distance dependence formulas over here. So in this experiment, we set up a phone with a magnetometer app at different distances from a bar magnet and collected data about the magnetic field. We assume that the bar magnet can be treated as a perfect dipole with a separation S, and we also assume that there are no other forces acting on the phone besides the magnetic force from the bar magnet. The system in this experiment is the magnet and the phone collecting the data. The surroundings is everything else. And then the initial conditions are that without the bar magnet, the phone was in a magnetic field of 0. So our experimental procedure, we downloaded a magnetometer app and then accounted for the Earth's magnetic field and oriented the phone so that the magnetic field of the Earth would not interfere with our data. And then with the phone in line with the Earth's magnetic field, we could put it in various locations compared to the bar magnet and calculate and record data of the magnetic field. So this is the data that we collected, and then data that we calculated. So we found n to be negative 3.0776. This is that distance dependence value. And then we can use that to calculate the magnetic dipole moment as 3.06. So this was the data that we collected for the off axis. The average magnitude of the magnetic field was 4.59 times 10 to the negative 5th Teslas. And then this is our code. We changed the mu mag to be equal to the one that I found earlier. Here. That is what we put as mu mag. And then made the equation for the dipole for the magnetic field, and then scaled everything, made our vectors, and then we have the arrows made, and then yeah. And this is what it ended up looking like. And it says that we had a magnitude, the magnitude of the magnetic field at 45 degrees was about 2.42 times 10 to the negative 5th Teslas. And then our experimental data was 4.59 times 10 to the negative 5th, so that's a little bit different. And then the difference could be from a few things, probably human error. The technology around the phone collecting the data could have interfered with the data, and then if the phone or meter stick were shifted at all, like during the experiment, so that they no longer aligned with the Earth's magnetic field, the data could have been skewed. So what if you hadn't oriented your experiment to compensate for the magnetic north and had instead laid out your meter stick at some intermediate angle? How would your results have changed? So the Earth's magnetic field would have interfered with the x component of the magnetic field that the phone measured, so that would throw off our calculations. And then if we did two identical magnets, how would our measurements differ? I believe that the magnitude of the magnetic field would double, and then the direction would just stay the same. So in conclusion, we were able to use an app to measure the magnetic field of a bar magnet and see how the distance dependence affected it. And then we got an experimental magnetic dipole moment of 3.06 amperes squared, and then a distance dependence value of about negative 3.0776 meters. And then our experimental value for the average magnetic field off the axis was 4.59 times 10 to the negative 5th Teslas, while the computational model calculated 2.42 times 10 to the negative 5th Teslas. Thank you.